Hey guys, what's up? Today we're looking at solving a differential equation using separation of variables. And we want to go over the steps. I've actually thrown in an initial condition here just to make things a little bit more exciting and just to see what happens whenever we have an initial condition and we're using separation of variables. I'm actually going to solve for the constant before I try to solve for y in this one. So number one, separate the variables on the left and the right. So on the left, I only want one variable. On the right, I want the other variable. And then I'm going to integrate both sides with respect to the variable that's on that side. The next step, don't forget a plus c. You need a plus c either on the left or the right. I usually like to put it wherever x is. Number four, I'm actually going to skip that one because I'm not going to be able to solve for y in this example. So actually what I'm going to do is I'm going to solve for the constant integration first, because even if I were going to solve for y, it would be much easier for me to go ahead and solve for the constant and then try to solve for y. But this one we're going to see doesn't even pan out for solving for y. So the solution here is just going to be some algebra. We need some algebra first to separate the variables. Now on the right, I have y plus 1 squared over x squared. On the left, those are already pretty easy to separate. So I'm just going to rewrite this thing as y times natural log x. Notice it's dx over dy, so that's a little bit different, but not too hard to, it's not too different. So the top over here is going to be y plus 1 squared. The bottom is going to be x squared. Now to separate, I'm going to multiply both sides by x squared to get the x squared over here. I'm going to divide both sides by y to get rid of this, and then multiply both sides by dy. So this is going to be x squared natural log x dx equals, and if I do all the steps, it'll be y plus 1 squared over y, and then don't forget we're multiplying by dy. So now our variables are completely separated. We're good to go. Now what we have to do is integrate. So on the left, I need to integrate with respect to x. On the right, I need to integrate with respect to y. So I've got a little bit tougher integral here. This is integral x squared natural log x dx. And how do we integrate that? Well, we need to integrate this using integration by parts. So I'm going to use u equals natural log x and dv equals x squared dx. And I pick u from my Lee 8 priority list. So log first, inverse trig next, algebraic or polynomial next, and then trig and then exponential functions. So du is going to be the derivative, which is 1 over x dx. V is going to be the integral, which is 1 over 3 x cubed. My integral is going to be 1 over 3, so uv, 1 over 3 x cubed natural log x. 1 over 3 x cubed natural log x minus integral v du, so integral 1/3. And now if I multiply x cubed by 1 over x, I get x squared dx. And now integrate that, get 1 over 3 x cubed natural log x minus 1 over 9 x cubed. And I'll stick my plus c right here with the x terms. So what I've got so far is 1/3 x cubed natural log x minus 1 over 9 x cubed plus c equals, and now I need to integrate the function on the right. So the integral of the function on the right is actually not too bad, because what we just need to do is square out the numerator. So it's just y squared plus 2y plus 1 all over y dy. And just some algebra to simplify that makes it easier, and we get y plus 2 plus 1 over y dy. And integrate that, we get 1/2 y squared plus 2y plus natural log absolute value of y. So that's what we have on the right side. I don't need a plus c over there, because if I had one, I would just move it to the left and combine it with the c that I had there to get just one constant. So that's what this c right here represents, is that one constant. So this is going to be 1/2 y squared plus 2y plus natural log absolute value of y. And that is really just your implicit solution right there. Now, I have added an initial condition. So what I need to do is I need to say, okay, so if x equals 1 and y equals 1, what is c? And now I can work that out. So I'll get 1/3 times 1 times 0, because natural log of 1 is 0, minus 1/9 times 1 plus c equals 1/2 times 1 plus 2 times 1 plus natural log of 1, which is 0. All right, so now this is going to be negative 1/9 plus c equals 1/2 plus 2. That's going to tell me, if I solve for c, c will be 47/18. Now I can substitute that back into this equation right here and get my implicit solution, which is 1/3 x cubed natural log x minus 1/9 x cubed plus 47/18 equals 1/2 y squared plus 2y plus natural log absolute value of y. And that is our implicit solution. Notice it would be extremely difficult to solve for y because of the natural log. If I had just a y squared here, I would get a plus or minus a square root, maybe using a quadratic formula, but that's still not very nice. I don't know, that's really complicated. So this is just better to leave as an implicit solution in this one. That's how we do it.